Good day. In this lecture video, we will be discussing logical connectives and basic logical operation. So what is a logical connective? So a logical connective is a symbol or a word used to connect two or more sentences of either a formal or a natural language in a grammatically valid way. So I think I have already discussed or introduced this on the last lecture video. Basically, a logical connective is used when you want to combine two or more proposition in a compound proposition. So, common logical connectives are and or. There are many more, but this actual video I'll be just introducing the and or. And as we move forward or go further along through this topic, we will be introduced with more logical connectives. So here are the example. So you have two primitive proposition. So this is primitive proposition since this sentences or this proposition only contains one proposition. No? So here we have the P1 and the P2. P1, the proposition P1 says that it is sunny, and the proposition P2 says that it is Monday. When we want to combine this so that we can create a compound proposition, we can use a logical connectives. So in this example, we use the AND logical connective, and thus we have this compound proposition that says it is sunny and it is Monday. Okay, now let's proceed to truth tables. So truth tables are usually used on compound proposition. That is, if you want to find all the possible truth values of a compound proposition that you have. So basically, the possible truth value of a combined proposition can be represented using a truth table. No? And if you want to construct a truth table, then for example, if you have a compound proposition that contains n proposition, that means that your element should have 2 to the n elements, or 2 to the n should be, that means that you will have 2 to the n elements in the truth table. So for example, there are three propositions in your compound proposition. That is the P1, P2, and P3. So that means that there should be 8 elements in your proposition. So here is an example of that. So these are your propositions. You have P1, P2, and P3. As you can see, we we write here all the possible combinations of their truth value, possible combinations of their true and false value. And here we will write the last part or the last rows of the truth table should contain the last or the final truth value of these three proposition. So it actually depends on what connectives you are using to be able to find the final uh, pro truth value of the propositions, the compound propositions that you have. Okay, so I hope that you completely understand that. Don't worry, we will go through more examples further. Okay, so here I will introduce the basic logical operations. Basically, basic logical operations are more like logical connectives that I just discussed. Logical connectives are more on what to say, a word, but in a logical operation, there is a value involved there. So So here we say that that some logical connectives are logical operation. Okay, here are the three most basic logical operations: the conjunction, disjunction, and negation. Okay, first we will discuss the conjunction. Conjunction, if we this is the end in the connectives, the logical connectives. So Here is an example of how the conjunction is used. So basically conjunction is just the end. So here let P and Q be the propositions. That is, if we use the conjunction in P and Q, then we denote it to something like this. So this is its symbol. No, it is denoted this way logically if we use the and or the conjunction logical operation. So this is actually read as P and Q. So here is an example as the similar as the example that we have in the previous slides. It is Monday. P is proposition that says it is Monday. Q is a proposition that says it is sunny. Thus, P and Q is basically it is Monday and it is sunny. So that's just it. Okay, so if we want to find all the possible truth value of P and Q, we have this truth table. Okay, so as you can see here, if both P and Q are true, then its final truth value of the P and Q should be true. The rest should be false. So P and Q is basically only true when both P and Q are true. So keep that in mind. Next is the disjunction. So what is a disjunction? Disjunction is the or in the logical connectives, and it is denoted in this symbol, the V symbol. So here, this is the formal definition that P and Q be propositions. Thus, the disjunction of P and Q is denoted as P or Q and is read as P or Q. Okay, so here in the example, we have two propositions again, the proposition P and Q. If we use a disjunction on both of this proposition, we will have this Monday or it is sunny. So the final truth value when we use the disjunction on propositions is represented in this truth table. We see that if one of P and if either P or Q is true, then the final value of P or Q is true. If both P and Q are false, then that means P or Q should be false. Okay, so keep that in mind as well. Last logical operation is the negation. So negation is not actually a logical connective. It is just basically the negated version of your proposition. So here is a formal definition. The negation of P is denoted as this one and is read as not P. So the opposite of your proposition is what the negation is all about. So in the example we have here, if P is Monday, then not P should be it is not Monday, since not P is the negation of P, the complete opposite of your P. So if you present that on the truth table, it will have this value. So meaning if we have P as true, then its negation should be false. And if P as false, then its negation should be true. Okay, so that is all for this lecture video. And see you on the next one.